Search a 2D matrix. You are given, let me actually reset this, start that timer. You are given an m by n integer matrix with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in matrix or false otherwise. You must write a solution in O log m by n time complexity. Okay, so first of all, I'm just gonna comment that out. And let me just practice writing this boilerplate code again. Just like the main important thing is here. Search this function signature, like making sure that I have practice writing this. If it's inside of a class, I need to have self in Python. And then we had a matrix. I guess we can also add the fact that it's a list of lint of integers, I believe. Or maybe I'm just speaking from memory. And then target, I think it's also integer. Yeah, it's an integer matrix. And then we want to return, yeah, boolean at the end. And I believe that's good. Let me try resetting this. Search matrix, target. Yeah, cool. All right, beautiful. All right, let me try using my definition, see if it breaks anything afterwards. And then we want to so these are the two properties. We want to see if the target is in matrix, and it's got to be an O log m by n time complexity. So we can't just go through all of the elements and try finding the target that way, because that would be m by n time complexity, right? It would be O m by n, because then we'd be looking through all the elements, but we want log. Log implies binary search, and I chose this question from the binary search category in the NeetCode 150. So I already know it's binary search, but let's see how we can do this. So we have two examples here. In an actual interview, sometimes I'm not giving examples, like worst case. I'm going to use the examples for today, and then let's see if I can practice in the future and build my own examples. Matrix examples are hard though. Like, I don't know, building these examples on your own. I mean, at least they take time, which is the thing. So 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. Okay, so each row is sorted in non-decreasing order. So that means it can be increasing or equal. So like 1, and then you could have potentially another 1. And then or numbers that are greater in this row, in 1, 3, 5, 7, or 10, 11, 16, 20. And then the first integer of each row is greater than the last integer of the previous row. Oh, okay. So 10 is greater than 7, 23 is greater than 20. Cool. Alrighty. So it seems like yeah, it's a special type of binary search inside of a matrix. Interesting, because before we can imagine this entire or maybe I'll look through all the examples before starting my brainstorming session. So target is 3, we have 3 over there. Target here is 13, there's no 13 here. Yeah, false. Okay, and then I saw the constraints kind of hint down there. I guess the constraints to consider would be matrix. What can it be empty? How small can it be? How big can it be? And I guess that considers both the outer and inner matrices. What are the actual values inside the integer, inside the matrix? Like, what's the kind of bound on that? Though I don't think, like, of course we want the target to match the like an element inside the matrix for it to be true. Otherwise, it's false, right? But then the actual value itself, I don't see like a time complexity difference depending on the value. Same thing with target. Like, what can it be? Can it be negative integers, positive? Again, I feel like that doesn't really matter, but it doesn't hurt to ask bounds. Duplicates, I think we kind of got that from this non-decreasing order. We know it's sorted, so I guess that's a good thing to note. What else would be important? Sorted, duplicates, even, odd, and all that stuff, but I don't think that's important, so let's check down here. So M and N, the definitions. So it can be empty, it has to be at least 1, it can be up to 100, and the actual values can be from negative 10 to the power 4 to 10 to the power 4. Okay, cool. So it can be negative. Yeah, that doesn't really change much. We do know that we need this time complexity. Now, how would I choose the middle? But I choose, like, so basically this entire thing. Okay, now I can do brainstorming. There we go. So 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60, right? And the original binary search, we'd have just a regular list like this. Then we go into the middle, right? Somewhere here, maybe 16 or something, I don't know. Get the middle, see if it's less than or greater than the target, and then okay, let's see if I get this right. If it's less than the target, if 16 is less than the target, then you want to go into the right, because the target is greater than 16. If 16 is greater than the target, right, that means that the target is lower than 16, so it's going to be in this left kind of array. And then you could like get the middle over here or get the middle over there, and then keep on keep on doing that process. Now that we have like a matrix, maybe we can see, maybe we can try and do that for like the rows, like find the midpoint for the row, check the first element, see what the situation is like, and then go into the first row or last row. The thing is, what if it's over here? What if like the value is 16, right? Coming in here wouldn't actually be that useful, but I guess we can like check the target. We notice that it's less than 23, and then we come back here and then go into the middle for this. Yeah, that's my solution. Like, we have like a row situation going on, and then I guess space complexity might also need to be. Does space complexity need to be linear? Because then I could just put this into a list and then run binary search like normal. I'd imagine it is. I don't know. That'd be a good question to ask for the interviewer. And what if I use the actual element here? Like, so I count. How much is this? 4 by 4? No, 4 by 3, 12. So 6. So the index 6 would be. How can I calculate that? Well, it's going to be in the second position, and it's going to be like 16 or something. From there, can I go left or right? I don't know, it's a bit hard with the matrix to visualize that. That's why I like putting it like this. Or maybe there are different like conditions to consider. Maybe. Okay, so if it's less than 10, we definitely know it's in this kind of area here. Okay. If it's greater than 10, then it can either be in the remaining over here, or it can be in like afterwards, you know, in the second. So how can I make my work easier? Can I first solidify on a row and then solidify on, you know, the individual elements in the columns? Maybe that'd be a good strategy to start off with. Yeah. There might be some duplicate work going on though, the way I'm like thinking about it. The 10 situation works for this, but it doesn't work for down there. Maybe check the first element for going like up and check the last element for going down, maybe. So if the target, for example, let's say it's 3, if 10 is less than 3, then we go in that direction. If 20 is, wait, how do I, hold on, now I'm confused. I need to know whether the target is up there or down there, because I know to check 10 because we want to find 3 and we want to actually move up from 10, from like the row, the second row. And then if the answer was 34, I want to check 20, right? And then go down. But then, and I do know the target, so maybe I can leverage that? I don't know, I feel like this is weird. This is overcomplicating it, maybe. Let me try, we're 13 minutes in. I was gonna say, let me try writing just a normal binary search solution after just putting it into a list like this. I feel like I'm not getting the true value of this question though if I do that. And I want to put more effort into trying to solve it as a matrix rather than moving it into a different data structure. Or, you know, moving it into like a linear format, however you want to call it. Okay, well, simply not doing anything and just feeling like I don't, you know, feeling stuck is not going to help. So I need an example. So I'm just going to I'm brainstorming. I'm writing this on like like I have like this whiteboard over here. It's gonna be a little bit hard for me to write it there, but I'm just like writing things down, and then I'll see if I can translate it over to the whiteboard on my computer. I'm just trying to figure out a strategy. I think I got something like, but maybe I'm just like overthinking it and not sure what to do. So if we have this kind of, taking a look at example 1, right? And we know the middle row is this one right here in the middle. Okay. And we know the target is 3. Okay. Now, let's do a check. Is the target less than 10? It is. So we move. We don't even consider any rows below the second row. We just go up, right? Let's assume that's not true. Let's assume it was 34 and we did that check. Is 34 less than 10? No, it wasn't. Okay. Well, now we can do another check. We can go for we have an else case and be like, okay, well, it's 20 greater than or what is it? Is the target greater than 20? And if yes, then we could not consider anything above the second row and go down. Okay? And then go down. And when I say go down, we can if there's a bunch of different rows, we can go to the middle, right? And then continue that process back and forth. If that's not true either, right? If imagine we got 16, right? Is 16 greater than 20? No. Well, then we just stay on this row, and we know that the value is somewhere in here, and we can begin the binary search process on this row itself, similar to how it was done before in in just normal binary search. So I think that's just the added nuance to this question. So I'm at 17 minutes. With that approach in mind, that makes sense to me. Oh, I didn't draw it out for you guys on the whiteboard, I guess. But hopefully my explanation was okay. Let me try coding it out. I won't do just the regular binary search process like this, even though there's no constraint on the space complexity, just so I can get the value of trying to do it as a matrix. Now let's do a binary search on the rows first. So binary search on rows, and how do we do this? Mid row. Length of matrix divided by 2. I'm going to do just the left and right. 0 and length of matrix -1. Oh, wait, hold on. Left press right, divide by 2. And surround that by brackets. Okay. I'm probably going to have to be reading this to left row, right row, maybe. Let's see. So now we have this middle row, okay, and then we need 2 checks. If this element here, if target is less than mid row 0, there's going to be at least one element, so I think this is fair game, I think. And we can do that, right? Because right, or maybe up, down, top pointer, bottom pointer. T and B. Let me do that actually. T and B. It's a bit weird, but I'm used to like seeing L and R for left and right. B. Yeah, the bottom one moves up by half, so it disregards the bottom half. If target is less than or mid row -1 is less than target, then A is equal to mid row +1. And else we just stay on the same row and do binary search on columns. And that'll just be the normal binary search we all know of. And then we want to return true or false. So maybe at the end, default can be false, and then in here, if you find something, it could be true. So I'll do a left and right, 0 length matrix, mid row. Well, it doesn't really matter. It can just be 0 as well, because all the columns, all of them will be of the same length, right? There won't be just one row with length 3 and then one row with length 4, for example. Mid column. Yeah, I'm talking about rows and columns. Yeah, cool. I guess I was just mixing up the rows and columns, like terminology that I was using. I don't think that made much sense. Oh my god, I can't speak. I'm sorry. Let me continue on. Mid row, left plus right, and if target is less than matrix, mid row, mid column, then we know that we want to move the right, and look at and focus on the kind of left portion of the row. And then if it's the other way around, then we know, we'll need a while loop as well. Yeah, we know that we can ignore the left portion and we only focus on the right. And if it's equal to each other, then we can return true. All right, and then that, and then maybe do this, or hold on, maybe do left is greater than right, so like that, and same thing here, while top is less than bottom. I'm very curious to see if this works. Let me do a dry run just so I don't get used to just running the program and not knowing how to debug it if it's wrong. So we have TMB, 0, we're at 24 minutes. 0, length matrix -1, right? So top would be this top one, bottom would be the bottom one. While t is less than b, row, t plus b, so 0 plus 2 divided by 2 is 1, so that'll be this one. If target is less than mid row 0, which it is in this case, we go into here. B is equal to mid row -1. and that'd be 0. So now T and B are equal to each other. So we do this, skip that, and then come here, 0, 0, divided by 2, and then we reach here, and then we do this. If target is less than mid-row 0, it can be, right? Because, well, it's not, because 3 is not less than 1, okay? Then mid-row minus 1 is less than target, and 7 is not less than 3, so we're on this kind of section here. How do we search the columns? So left and right, matrix. So we have the left is 0 and right is 3. 1, 2, 3, 4 minus 1, 3. Yep. And while left is greater than right, mid column left plus right divided by 2, 0 plus 3 divided by 2, 1. It's going to be 3. So both of these are going to go through, but here it's going to else and return true. And we don't have to even worry about the while loop, actually. Interesting. Same thing with this scenario here. We have 13. So when we come here immediately, well, actually, we won't even go through the B and A scenarios. We'll go here. Left and right, and then we'll do left plus right, and it'll be at 11. And target is, so 13 is less than 11. That's not true. So we have 1, 1. Target is greater than this. That is true. So left is equal, left is equal to mid column plus 1, which is 16. So now 16, and this is 20. Okay. So hold on, 2 and 3, 2 plus 3 is 5, 5 divided by 2 is 2.52, so 0, 1, 0, 1, 2, so it'll be 16. And then is target less than matrix, so is 13 less than this? Yes, 16 it is. So we move this down to mid column minus 1, which is this row 2, 1, and then this won't run true anymore, but this one will run true. So can I actually return false when I come here? I think I can. And this is a different scenario when we don't even find, I don't even know if this return false would return true. I don't know. Like, I don't even know if we'll actually ever get here. Maybe, maybe not. I don't know. Let's see. Let's run it. Uh-oh. Oh. My bad. Matrix mid-row and matrix mid-row like that. Alrighty. Ah, bummer. Output expected true. Wait, but why didn't it return true though? Huh? Bro. I ran through that dry run. Did I run through the dry run incorrectly? After it does this scenario, this one runs true. Okay, and then it comes to the first row, and then it does this, and coincidentally for us, mid column 0 plus 3 divided by 2 is actually going to land on 1, so it should be it should return true immediately. Huh. Maybe I'll print out matrix this. Just kind of confirm maybe I'm doing this wrong. 30 minutes. Oh, it's not even reaching here. What? Whoa. Okay. T is less than b, and this is what t and b are equal to. T plus b divided by 2, 0 plus 2 divided by 2 is 1. And if 3 is less than the matrix mid-row 1, 0, which is 10, right? B should be equal to mid-row minus 1, 1 minus 0. So now both of these are 0, okay? 0 plus 0 divided by 2 is still 0. And then we come here again. Matrix 0, 0, right? 3 is less than 1? No. Is 7 less than 3? No. So we should come here. What's going on, bro? What's going on? Okay, well, let's print out mid-row and see what's going on. One. Oh, why am I doing A and B? What in the world? What in the world? T, bro. T. Where did A come from? Okay, well, hold on. It just ran once, though. That's still not correct. Is it because of this check? Oh. Hold on, let's see. Oh shoot, I submitted it. Okay, well, it's good to know that I didn't do that right. I was close though, jeez. Okay. What is false? I mean, fair enough. Like, how am I even supposed to deal with that scenario? So both T and B would be equal to each other. Right? Like, am I mistaken? Yeah, because both of them are they'd be the same row. Length of matrix minus 1. Yeah, 1. Yeah, so 0. If target is less than matrix, so if 1 is less than this, 0, 0, it's not. So B is equal to mid-row minus 1. No, sorry, this is not true, so we check here. Is 1 less than 1? Still not true. So we should come here. And left, right, and all that, and then -1. This. Like that. Let's try. Nice. Now, I am interested about these return false statements. Not sure. Not even, like, I feel like I can, like, pass this without that. But I don't think that's... Oh, rip. Never mind. Never mind. So I guess when this fails, I need a return false. Alright, cool. Good to know. Good job, man. Good job.